our lesson here. It's still Unit 4. So we're going to spend this week on Unit 4, and then next week we'll do some review, and we'll have the test coming up for trigonometry. Today is applied trig, which means we're looking at real life problems, applications that you can use trigonometry for when you need to find a side length. And that's your learning goal. I can solve real world problems with trigonometry. So there's a couple of vocabulary terms that'll show up today. Knowing these terms helps you understand what we're talking about. It's not something you would be tested on, okay? But if we talk about an angle of elevation, then that's talking about from your viewpoint in this real life situation. Are you looking up? That would be elevation, okay? Or if you are from your viewpoint looking down, that would be depression, okay? So, you know, you could be looking up at a tree, standing on the ground, that'd be an angle of elevation, your viewpoint. Or if you are looking at the edge of a cliff, looking down, that could be an angle of depression, okay? So it's just to tell us if we're looking up or down, what that angle looks like. And this is our first interactive slide. So we have a picture here of a salvage ship. And down at the bottom, straight down, there is a scuba diver. And then over here, this mess is a wreck of some sort under the ocean. And the description here says that a salvage ship uses sonar to determine that the angle of depression to a wreck on the ocean floor is 13 degrees. So we're using that angle of depression. So from the boat's viewpoint, it's looking down or using that radar to get a reading downwards. And this measurement here is 13 degrees. Because of the way this problem is set up, you're going to see that this angle here is going to be an alternate interior angle. So this angle is also going to be 30 degrees because these are going to be right angles. It says the depth chart shows that the ocean floor is 40 meters below the surface. So our scuba diver went from the surface to the floor, and he is straight down, okay, 40 meters. And then our ocean floor surface is totally horizontal in this perfect problem. And so this is creating a right angle here between the depth and the distance he has to go to get to this wreck. What equation would be used to find how far the diver must walk along the ocean floor to reach the wreck? We only know that the angle of depression is 13 degrees and that the scuba diver went 40 meters straight down. But that's enough information to actually use one of these equations to solve for this distance he has to go, which is x. So this is just a click and drag. Which of these do you think is going to be the correct equation that we're going to use to solve this problem? I have 9 of 20 responses so far. We're up to 14 out of 20, maybe about 30 more seconds if you haven't picked one of these yet. All right, let's see what we're coming up with. All right, so it looks like definitely we're using some tangent function. We kind of mostly agree on that. Cosine is not the correct trigonomic function here. So if you think about SOHCAHTOA and what we have in the picture and what we're trying to figure out, tangent uses opposite over adjacent. Sine and cosine both use hypotenuse. And so the hypotenuse is this dashed line, which we don't know and we don't need to find out. So it's definitely not cosine or sine. It's going to be some function of the tangent. And looks like we're kind of split between the first tangent one and this third one down. I can't really see it anymore. So if you look at what we're taking tan of, the variable is here. This means we don't know the angle. If the variable is somewhere in the ratio, like we have on these two, that means we don't know a side length. So if you look at this right triangle here, or this one above it, they're the same right triangle, just kind of oriented differently. We do know the angle measure. We don't know the side length. Okay, so definitely not the first one, tan of x. That's not true. We know x. In this case, this x here is not the unknown. We know the angle measure. It's tangent of 13. So it's one of these. It's either tan of 13 is x over 40 or tan of 13 is 40 over x. And just depends on how we set that up. So if I use where I could see the angle and I have to compare opposite over adjacent, the opposite side to the 13-degree angle is going to be 40. And then x to the 13-degree angle is adjacent because it does make up the right angle and the right triangle. That's the adjacent leg, that's the opposite leg. Or if you're looking over here, because this angle is also 13 degrees, this is the adjacent leg and this is the opposite leg. So SOHCAHTOA, T-O-A, tangent is opposite over adjacent. So you should have this one right here. And that is the equation that we're going to solve. Okay, so we're going to solve for x and round our answer to the nearest tenth. And I mean, the equation's already set up, so all I got to do is isolate x and figure out how to do that. And so, you know, when you're looking at an equation, you can always do the same thing to both sides of your equation. And so the variable being in the denominator is not exactly where I want it. So I'm going to multiply both sides of this equation by x. So I'm going to come over here and multiply by x and by x. Multiplying both sides by x. So those cancel. And I'm just going to rewrite what I have this time, which is x times tangent of 13 equals 40. And so we want to isolate the variable x. X is being multiplied by tangent of 13. Tangent of 13, this is its value is a ratio. It's a numerical value. So this is like a number that I could just divide away to get rid of it. So I am going to divide both sides by tangent of 13. And tangent of 13 divided by tangent of 13. Anything divided by itself is 1, so that cancels out. And now what I'm left with is x. equals 40 divided by tangent of 13. And now to evaluate that, which is just some numerical value, I'm going to use a calculator. And so I have been showing you guys with the Google calculator how to do this. You can do this with any calculator, but all calculators are slightly different, so the way that you go about getting the correct answer might be a little bit different. And so the first thing you want to do with this calculator here, or any calculator, is that you always have an option between radians and degrees. And so if you look at your angle measure, we're working with degrees, 13 degrees. So I want to make sure DEG is bolded. And that means I'm on degrees for this calculator. And then all I need to do is figure out what is 40 divided by tan of 13. So I'm going to just type that in, 40 divided by tangent. It'll automatically pop up parentheses. I'll type in 13. I'll close the parentheses. And then I just need to click equals. And I'm going to round my answer to the nearest tenth. So when we do round our answer, anytime you round, you would then switch to that wavy equal sign, right? Which means approximately equal to. So I'll try to draw that in as best I can. There we go. Approximately equal to. Okay, so I'm going to come over here, click equals. I'm ending up with 173.2590 and so on. Rounding to the nearest tenth means I need to look at what's in the tenths place, which is a 2. And I look next to the 2, I see a 5, which means I need to add 1 to 2. So this is going to round to 173 and 3/10. And then we are dealing with M, which stands for meters. And I put an extra number in there. There we go. 173 and 3/10 meters. Whenever you do these problems, always check that your answer is reasonable, okay? If I ended up with something that was negative, that would not be a reasonable answer. If I ended up with something like 1 meter, that would not be a reasonable answer. 173 and 3/10, that's a reasonable answer. That if this is a 13-degree angle, 40 meters down here, this is going to be a very long distance, and then this amount here, this seems like a reasonable answer, and this is the correct answer. Okay, do you guys have questions on what we just did with that problem? Okay. Virtually, do you guys have any questions? Making sense, okay? So we're not really learning any new math. We're just applying math we've already learned to problems where there's a little picture or description to go with it. Okay. I'm going to move you guys to the next slide. And if you didn't get finished copying that, I will put it back to that in a little bit here. So this is another drag the icon problem. And so we have a picture, a lovely picture here, and a description that says, suppose you are a lifeguard looking down at a swimmer in a swimming pool. Your line of sight forms a 55-degree angle of depression because you're looking down, so that's an angle of depression. You are 10 feet up in your seat. How far is the swimmer from the base of your lifeguard stand? So we can draw a picture or look at a picture to go with this scenario. Here is the lifeguard that you are in your chair. You are 10 feet up in the air, your line of sight, if you look straight across, that's flat, horizontal, but looking down, your line of depression, so 55 degrees down, creates this line of sight to the swimmer, which is in the water. This is creating basically two right triangles that are the same right triangle, just oriented differently. So this 55-degree angle here and this angle here is also 55 degrees because they are alternate interior angles. And I want to know, how far away is the swimmer? This is our unknown. X distance, X feet. And I am 10 feet in the air, and that's all I need to know to figure out how far away he is. So you're going to drag your dot to which equation you think would represent this problem. They wrote SOHCAHTOA out for you here. Kind of a different way of writing SOHCAHTOA, where SOH, they kind of wrote it just in the way it would show up as if you were using sine, and then you would have opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. I have 13 responses. So where do you think you should drag your dot so that you're using the right equation? Okay, let's see what you guys are coming up with. There's a couple on this one, a couple here, none on this one, and then the rest of us are here. So if we look at this right triangle that's created, the hypotenuse is this green line. This green line's distance is not given, and it is not needed. So we wouldn't be using a function, a trigonomic function that includes the hypotenuse. So it's definitely not the sine option. And there's no cosine option, but it's going to be a tangent option because we know this leg and this leg, and with the perspective of this being 55 degrees, this would be the adjacent leg, and this would be the opposite leg. So that is tangent. Tangent is opposite over adjacent. And so it looks like most of us are now on the correct one. Tangent of 55 degrees is opposite 10 over adjacent x. All right. And so what you're going to do is solve for x and round your answer to the nearest whole number.